Question 2. By applying the horizontal line test, determine whether each of the following function has an inverse function. Okay, so we normally learn, if you want to check if it's a function or not, we have to do the vertical line test. So if a vertical line cuts the function at one point like this, okay, it cuts here at one point. If you move the vertical line, it cuts here at one point. If you move the vertical line here, it cuts at one point, means if the vertical line only cuts at one point, that means it is a function. But now we want to find if the following function has an inverse function or not. So now we have to know, if you want to find the inverse function, okay, if this is our function, the inverse of this function will be the graph flipped in the y equals to x line. So when the graph flips or the graph turns here, this is our inverse function. So if this is fx, this will be f inverse x. The graph will rotate 90 degrees. Okay, so when you flip the graph, if you want to check if it's a function or not, now the vertical line test will become a horizontal line test. Then only we'll know if it's a one-to-one or many-to-one function. Okay, so if you want to check inverse function is a function or not, you must use the horizontal line test. Okay, so now we check whether it cuts at one point or not lah. Okay, when you bring up, it cuts at one point. So let's bring the horizontal line here. Okay, so this one, the whole graph, it only cuts at one point. Here 1 point. When we move this up, here 1 point. So when it only cuts at 1 point, that means this is a function. This is a function. Okay, then we bring it here. Here also it cuts at 1 point only throughout. Okay, it only cuts at 1 point. When we move this up here, it also cuts at 1 point only. So this is also a function. For this graph, as you can see here, it cuts at 3 points. So this one, not a function lah. Okay, if it cuts at more than 1 point, it won't be a function then. So not a function.